Hey guys, Mr. Langley here. Today we're going to look at section 2.5, which is algebraic proof. So you see our targets, looking at these properties of equality and see how they help us create these algebraic proofs. Additionally, we're going to be looking at properties of congruence as well, and we're going to see a lot of similarities between these properties of equality and congruence. So back in section 1, when we looked at inductive reasoning, we were saying that once you have your conjecture, you can either prove that it's true or find a counterexample to illustrate that it's false. So we looked at counterexamples, but today we're going to be starting to look at proving things to be true. Logic, definitions, properties. Okay, we saw that with deductive reasoning, even though we were first introduced to this idea with inductive reasoning. So we have 8 different properties of equality here. Now, I don't want you to get overwhelmed with this. These are all very straightforward. About half of them you've been doing for a couple years now, even without knowing what they were. These first 4 properties here, addition, subtraction, multiplication, and division properties of equality, these are things that you've been using to solve equations ever since pre-algebra. Whenever you're taught to keep the equation balanced, you're using a property of equality. So let's start with addition here. The addition property of equality says if you have 2 terms equaling each other, if A equals B, then A plus C equals B plus C. You're allowed to add the same thing onto both sides of the equation, and it stays balanced. That's the addition property of equality. Same thing holds true with subtraction. You're allowed to subtract away the same value C from both sides, and the equation remains true. Multiplication, same thing. Multiply both sides by C, the equation remains the same. Same thing with division, with the one caveat that, of course, you cannot divide by 0, but otherwise, you can divide both sides by C. The equation remains the same. These last 4 properties that we have, reflexive property, symmetric property, transitive property, and substitution. Reflexive property of equality simply states that something is equal to itself. A equals A. And you might be thinking that that seems so basic, why do you even need a property for that? Well, we're going to come up with examples, different cases throughout the year where we're establishing that the same quantity that's used in this part is the same quantity that's used over here. Okay? So that's where the reflexive property will come into play. Symmetric property. You know something is symmetric, it's the same on both sides. Human body's thought of as being symmetric, right? Well, that's what we have with the symmetric property of equality. If A equals B, then B equals A. Okay? It's mirror images of one another. A lot of times we apply this property without even thinking about it. Okay? Say you're solving an equation and you get 3 equals x. A lot of times we, without even thinking, just put x equals 3 because we're used to going left to right. You're actually employing the symmetric property. Transitive property. If A equals B and B equals C, then A equals C. If that sounds familiar, it should. It's pretty much the same thing as the law of syllogism. If A equals B, then B equals C. Okay? You have that redundancy. You have that redundancy of the B. Okay? Cut that out, goes straight from A to C. That's the transitive property. Lastly, the substitution property of equality. Substitution applies to different values. So if A equals B, then B can be substituted wherever you see an A in an expression. Okay? Now you're substituting in a value when you're employing that substitution property of equality. Again, an idea that you already know about. Okay? Now you're just labeling it with a specific property. This is not new, the distributive property, but it's good to have a refresher of that. Distributive property says if you have the quantity A times B plus C, you're allowed to distribute that coefficient a to both terms, a times b plus a times c. This only applies when you have addition or subtraction inside the parentheses right there, connecting those two b and c terms. So we have an example here. Solving this equation, 4m minus 8 equals negative 12. This is a pretty simple equation that you probably could have solved a few years ago in pre-algebra. Well, we're going to solve it, but as we work through this, we're going to provide our justification on each of these steps. And we want to get into the habit of starting with given information. What has been provided for us? You can't just start in the middle by doing things. You need to start with what's provided. So here we have 4m minus 8 equals negative 12. That is our given. So I'm going to make a little chart here. And it's called a two-way table. And we literally copy down what we started with. And as we begin to solve this, we are going to isolate this m. That's our main objective. So to do that, we're going to reverse apply the order of operations. Let's get rid of this negative 8, this minus 8. So to get rid of subtraction, we are adding to both sides. So we could think of this as plus 8, and I know this might be a little bit of overkill in terms of what you're used to doing with solving an equation algebraically, but let's write the plus 8 there for now. We're adding the same thing to both sides. That's the addition property of equality. So I'm going to abbreviate this add POE, property of equality. So when we do this, negative 8 plus 8, that becomes 0. We are left with this 4m on the left side of the equation. On the right side, negative 12 plus 8, we are at negative 4. What we've done is we've simplified things. It's not a property. Okay? You're just simplifying the expressions on both sides of the equal signs. All right, again, our goal is to get that m by itself. It's connected with multiplication to the number 4. To get rid of multiplication, we need to divide. And if we're dividing on the left side, we divide on the right side. That's the whole idea in algebra, or solving a linear equation. So we are going to divide away, write that down. Divide both sides by 4, which we're allowed to do by the division property of equality. So 4 divided by 4 leaves us with just the m. Negative 4 divided by 4 gives us negative 1. And again, we are simplifying. And there's our final answer. And m equals negative 1. Similar type of example in number 2. But now we have a little bit more of a context here. What is the temperature in degrees Fahrenheit, F, when it is 15 degrees Celsius? We're provided with the conversion equation, Fahrenheit equals 9/5 Celsius plus 32. So, once again, we're going to start this with our given, which is really just rewriting our equation. F equals 9/5 C plus 32. Now, our goal in this case is to convert these 15 degrees of Celsius into Fahrenheit. So, let's replace that C with 15. We've made a substitution. Substitution property of equality. A lot of times you'll find with substitution we kind of leave off the POE. We'll just put substitution. All right, so now look at what we have here. F equals, our goal is to get the temperature in degrees Fahrenheit. So we could type this all in on our calculator. But if you wanted to do this by hand, 15 divided by 5 right here is 3. And you have this 9 in the numerator, so 9 times 3 plus 32 kind of goes along for the ride. We're simplifying right now. 9 times 3 is 27 plus 32. Still simplifying. Part of the same step here. We've got 59 degrees Fahrenheit as our F value. We made our substitution. Ever since then, it's been a bunch of simplification. It's worth noting that when we were multiplying the 15, or actually this would have been division, 15 divided by 5, that is not division property of equality. When you're multiplying 9 times 3, that is not multiplication property of equality. When you're adding these two numbers, that is not addition property of equality. The reason is you're not doing it to both sides of the equal sign. When you stay on a single side, what you're doing is just simplifying. You're simplifying an expression. Now, these are very algebraic problems. This is algebraic proof, but you can do an algebraic proof in a geometry context. So one thing to remember here is a little bit about the notation. We talked about this in the beginning of the year. AB by itself represents a length. AB with this little segment bar on top, that represents the object itself, the segment itself. So, taking this into talking about segments here, example 3, write a justification for each of these steps. Well, just like before, let's start with given information. This picture provides us with a lot of given information. So let's kind of identify what that is. We have this length of nm equaling 2x. So nm equals 2x. We have this length of mo equaling 3x minus 9. And lastly, this no length is 4x minus 4. All of that is given. Doesn't have to be labeled as such. That's given to us from the picture. The picture is given information. We are trying to solve for x in this. We aren't really told. It just says write a justification for each step. Let's say we're solving for x. I mean, if we're finding side lengths, we could take that x value and then substitute it back in. But let's solve for x. Well, to relate these, chapter 1 idea, this length plus this length equals the full length. So in this case, we have our nm plus our mo length equaling our no length, the total. This segment length plus this segment length equals the full segment length. That is the segment addition postulate. Segment addition postulate. This piece plus this piece gives you the full length. All right, so now we have expressions for each of those segment lengths. Let's put those in. 2x replaces the nm. 3x minus 9 replaces the mo. 4x minus 4 replaces the no. We've made a substitution. Here, we're combining these like terms. 2x plus 3x is 5x. Minus 9. 4x minus 4. We've simplified. And at this step, you have a choice. Do we want to combine these single values, or do we want to combine these 5x and 4x terms? Let's go with the 4x. 4x. Let's subtract away the 4x from both sides. Now, you can write it as a separate step. Algebraically, I think a lot of us are in the place where we're not writing the minus 4x. You're welcome to if you want to write that. But we're going to subtract away the 4x from both sides. 5x minus 4x leaves us with a single x value. Minus 9, negative 4. And what we've done, subtract away from both sides, subtraction property of equality. Notice that I do like to abbreviate a lot, but you have to be careful. Subtraction property of equality, do not write just SUB, because we also have substitution that we use a lot. So for subtraction, I'll usually write subtract POE. For substitution, I'll write SUB-ST. But for neither of them do you want to put just SUB. Continuing on. Almost have x by itself. Let's add 9 to both sides. So when we are adding 9, we've got negative 4 plus 9 takes us to 5. This is addition property of equality. When we're solving for x, we're done with that problem. If you wanted to take this another step and find an NM length or an MO length or an NO length, you'd have another step of substitution. Our next problem is nearly identical in concept to what we just did, but in this case you're working with angle measures. So kind of take a guess here. Previously when we were working with the segment addition postulate, same kind of thing here, but with the angle addition postulate. So our givens in this case, we have 3 different angle measures. Now we do need to be specific and name these angles with 3 points. So let's say for our givens we have the measure of angle ABD. That is 3x plus 5. We have the angle DBC, so the measure of angle DBC, that's 6x plus 16. Lastly, this overall angle ABC is 8x. That's all given. So, kind of like what we did with our previous problem. We are now going to assemble these together with the angle addition postulate. So this angle plus this angle gives us the overall angle, measure of angle ABD, plus the measure of angle DBC, equals this overall angle, measure of angle ABC. And we've used angle addition postulate. Now we can substitute our expressions in for these angle measures. 3x plus 5 plus 6x plus 16 equals 8x. Again, that's a substitution. Combining like terms, we've got 3x and 6x added together, that is 9x. Similarly, we've got, oh, I messed up. I put addition when it was subtraction. 6x minus 16. So, negative 16 plus 5, we're looking at minus 11 right there. That's still equal to 8x. So all we've done is we've simplified our common terms. Again, adding the 3x and the 6x here, that is not addition property of equality because you're not adding the same thing to both sides. It's not like you're keeping the equation balanced and you're just simplifying a single side of the equal sign. All right, to continue on, you have some choices as to how you do this. What I'm going to do now, you might not initially think to do this, but I'm going to subtract away 9x from both sides, leaving us with negative 11. 8x minus 9x gives you negative 1x, or just negative x. Now, sometimes people avoid introducing negatives whenever possible. We've done a subtraction here, so subtraction, POE. Some people don't like to have that negative in front of the x, but it's fine because now to get this x by itself, negative 11 equals negative x, well, that means that positive 11 equals positive x. We have either divided both sides by negative 1, or we've multiplied negative 1 to both sides. Take your pick. This could be either multiplication property of equality or division property of equality. You could probably stop right here, or if you really wanted to show off, I mentioned this before, you have 11 equals x. Customarily, we go left to right, x equals 11. To reverse those like that, that is the symmetric property of equality. So one additional kind of bonus step. Symmetric property of equality. Think about what you're doing here. Algebraically, there's not really much new. Okay? You've been doing this sort of solving an equation for years now. What is new is just justifying it with the property. These properties aren't difficult. Familiarize yourself with them. Okay? We will be referencing them from time to time. All right, last couple things here. All of these properties up to this point have been properties of equality. We have an implied value that goes with these. This table talks about properties of congruence. Remember, if two things are congruent to each other, you're referring to the object, whether that's a segment length or an angle. A segment itself or an angle. With equality, you have an implied value. The values are equal, congruent objects are the same. So we have reflexive property of congruence, symmetric property of congruence, and transitive property of congruence. They're still stating the same things as the properties of equality, but now you're talking about segments are being congruent or angles are being congruent. Okay, we have segment EF congruent to itself. We could also say something like angle A is congruent to angle A. It's a reflexive property. Symmetric property, again, in terms of congruence, you're just reversing them. Angle 1 congruent to angle 2, then angle 2 congruent to angle 1. Transitive property, again, we said this is pretty much the same thing as the law of syllogism. Segment PQ congruent to segment RS, RS congruent to TU, then PQ is congruent to TU as well. So our last few example problems are just identifying the property that is being used. Make sure you identify either a property of equality or a property of congruence. For A, we have angle QRS congruent to angle QRS. This is the reflexive property of congruence. Letter B, measure of angle 1 equals measure of angle 2, measure of angle 2 equals measure of angle 1. This is that symmetric property, mirror images of one another. This is equality. We're talking about a value, an angle measure. There should be segment bars on this, a little typo there. So insert those because we're talking about congruence. AB congruent to CD, segment CD congruent to EF, so therefore AB is congruent to EF. Okay? Kind of start the train, as I like to think of it, transitive property. This is the transitive property of congruence. Letter D, 32 degrees equals 32 degrees. Once again, reflexive property of equality. One more page, 4 more example problems. Again, identify the property. Length of DE equals length of GE, so GE equals DE. Mirror images, this is the symmetric property of equality. 94 degrees equals 94 degrees, reflexive property. Zero equals A and A equals X, so therefore 0 equals X. This is the transitive property. Property of equality in this case. And then lastly, angle A congruent to angle Y, so angle Y congruent to angle A. Symmetric property of congruence. So, familiarize yourself with these properties of equality, these properties of congruence, and the only applications here are solving through an equation and giving a justification for each step.